Hi, and welcome to this new episode. Alright, on this episode, I'm going to be showing you how to add your wall load to your model. Okay, so along these beam lines, we can add a wall load. What wall load means basically is the walls that are actually going to be on resting on these beams. Okay, so if you right click on any of this beam and you go to edit loads, now it's going to give you so many options of loads, because we have different kind of loading that can be acting on your building. Okay, it's loading in the background. Okay, so you can see the load, but I made a mistake. I'm going to close this, and because I'm in story 2, so we'll do this on my story 1 rather, not on story 2. So my story 1, if I click on any of this beam, I will right click, come to edit load. Okay, so once you click on that, this is showing you that this is a triangular load, which is correct. Now let's look at this together. Because this panel is a square panel, it's going to give you a triangular load. In a case where you have a rectangular panel, it's going to give you a trapezoidal load. In some places along the long span, you have a trapezoidal. This is in the shape of a trapezium. This is also in the shape of a trapezium, because the load on your beam is also transferred from the slab. Okay, that is why your design, the loadings are coming from the slab to the beam to the columns send it down to the foundation. So this is exactly the load, how this load are going to be distributed on this beam. Based on this, if you look at this in form of like an X, this shape here is a triangular shape, this is a triangular shape, this is a triangular shape, this is also a triangular shape. So the load that this beam will be carrying is a triangular load. The load that this beam will be carrying is also a triangular load. The load that this beam will be carrying is also a triangular load. Similarly with this as well. But when it comes to this case, you will see the load that this beam will carry and this beam are carrying a trapezoidal load. This is also carrying a trapezoidal load. This is carrying a triangular load. This is carrying a triangular load. So that's basically what this thing is showing us here. So if you go back to the edit load, it's going to show you in the shape of a triangle, and then you can specify what type of load you want. So this is basically the main load that is coming from the slab that is acting on that beam. So it is called equivalent UDL. I think it's called equivalent uniformly distributed load. So that's basically the load that will be acting on this beam. Okay, so you can see here we have the point load, we have uniform load, we have partial load, we have trapezoidal load, we have wall load. Because this is actually a wall that we are considering, all I need to do is to come under my wall load and specify the wall load. So the load of the slab is different from the load of the wall. So the wall itself, it's a load that will be acting on top of that beam, aside from the load from the slab. And then you may probably be having maybe another additional load aside from the wall load, aside from the slab load that is acting on it. You may probably be having a point load as well, acting on that particular beam. So when it comes to that, when we get to this point, I'll be explaining that as well. So but on the case of this wall load, all you need to do is to specify the thickness of your wall, because this wall we use from the architectural drawing is 230 size of wall, which is your 9 inches block, and then the end and then the start all at 3 meters. That's the height of this particular wall, is 3 meters height. Now the value for your wall unit weight is always 2 point I think it's 87. I have really forgotten. I will encourage you get, so the value is 2.87. I will encourage you get the simplified reinforced concrete design by Victor Yenuga. I want to assume everybody going through this course is a civil engineer or a structural engineer, whether you are practicing or you are a fresh graduate or you are a student. Okay, so get that book by Victor Yenuga, is very important. It's actually going to really help you to understand these designs better. Okay, and again, I have a course on structural detailing manually using AutoCAD, and then there is a course on a structural design using RCD 2000 by the same Victor Oyenuga. It's very comprehensive. It's the best for every beginner. I will always encourage every beginner to get the course because it gives you deeper insight on design. Okay, because the truth is ProtaStructure does a whole lot for you in the background that you never get to really understand how all of these things really behave. Okay, so but aside from having this wall unit weight, there are other loads that sometimes we consider. So I always like to have it at 3.43. So and then I will click on and then I will click down here. Very important, because this is one of the areas a lot of people are getting it wrong. By the time you click on OK, that wall load will not be inserted. So all you need to do is to come back and click here. Once you click here, now the wall load will be inserted. Now you can as well, this wall load, edit it and create an opening for that wall, because the truth is there are designs that will come, you have opening, maybe like a door opening could be there, a window opening could be there. I always like to show people, but me personally, if you ask for my opinion, I will tell you it's very irrelevant, because by the time you introduce that opening, you probably have a window or a door there, and all those features, they have their own weight as well. So in essence, you are probably just doing a plus and a minus at the same time. So which is probably, maybe most likely not going to be very relevant. So you can remove all those opening if you want your job to be 100% accurate, because there is something definitely is going to do for you. But I don't think the result will be, the significance will be very much, although I stand to be corrected. So but this is basically how to get your opening. So if you have a 1200 by 1200 size of window, you can specify. You can see from here now to the bottom, architects call it seal level, if I'm not mistaken. You can type in seal level are always 900 when it comes to a square window like this, so that you can have 900 from here to here, have another 900 from here to here. Okay, so if you want to centralize the window, or the window is by the other side, you can just play around with this your dimension. So this is from here to here now is 1523. So if it is 1800, you can see the window has been shifted. So that opening can be created if you want, and all you need to do is to click on OK. If you go to your model, you are going to see that opening, that wall load has been created. Okay, I think that the opening is not reflecting. No problem, I will correct that even as we proceed. But for the purpose of this episode, I will click on this. I will just click on this beam that has that load. I will copy the load. I will click on OK. If I click on OK, this is telling you the G and then the Q, that's live load, dead load, And how many load do I have here? I only have the wall load that I inserted on that beam. So however, any number of load that I have inserted in this particular beam will reflect here. So the only loading that has been added to this beam is the wall load, aside from the load from the slab. Okay, so the wall load is what we have here. So if I click on okay, I have copied it, I can just highlight. Once you highlight all the structural members, from experience, it doesn't affect any other structural member once you click on paste, because it is only the beams that can have wall load. So no any other structural member that can carry a wall load aside from beam. So even if you highlight the whole structure and paste, only the wall load will be only the beams will be affected. So you can see my wall load has been inserted. Okay, so just like I said, you can edit the wall or edit the load by inserting a point load, inserting a uniform load, inserting a partial uniform load, trapezoidal load, and all of that. And as we proceed, I'll be showing you and I'll be taking you through that process as well. So by just editing this wall, this beam, you can see it's telling us all the loadings that are acting on this particular beam. You can see this is the self weight of the beam itself, and then this is the wall load that is acting on the beam, and then this is the slab load that is acting on the beam. So ProtaStructure is actually a very great software that a lot of people are actually really undermining the capability of the software. It's a very great software, I can tell you, for free. I click on OK, and that is that. So in the next episode, we are actually going to be analyzing this model, and then before we analyze it, we'll specify the characteristic strength of the concrete we want to use, the strength of characteristic strength of the steel we want to use, and then we'll specify the sizes of reinforcement on each of the structural members. Then we will now analyze it. So I will see you in the next episode.